Supervolcanoes are Earth's most destructive volcanoes, capable of catastrophic eruptions that can wipe out all life on the planet. But supervolcanoes are also incredibly rare. In fact, there have only been 3 in Earth's history, so we don't even know how they erupt, making them nearly impossible to predict. But researchers are getting closer to unraveling their secrets with some cutting-edge tech. They're building better and better tools to detect the signs of an impending eruption and potentially give us some warning before it's too late. First off, let's talk about what makes a volcano a supervolcano. It's not size that matters here, but power. A supervolcano is defined by its explosive potential, or the volume of ash and other volcanic debris it can hurl into the atmosphere all at once. To qualify as a supervolcano, an eruption needs to be a 7 or higher on the Volcanic Explosivity Index, or VEI. For context, the VEI describes Mount St. Helens 1980 eruption as a 5 and the 1991 Mount Pinatubo eruption as a 6. That means that supervolcanic eruptions are at least twice as powerful as Pinatubo and hundreds of times more powerful than anything we've seen in recent history. In the past 2 million years, there have only been 3 known supereruptions. The first was the Huckleberry Ridge eruption in Idaho about 2 million years ago. The next was the La Garita caldera forming in Colorado about 27,000 years ago. And the third was the Taupo eruption in New Zealand about 26,500 years ago. These supervolcanoes were so massive that they affected the entire planet, blocking the sun and causing ice ages. And it's estimated that each eruption ejected more than 1,000 cubic kilometers of debris. But while these eruptions had global impacts, figuring out how and why they occurred has been difficult because of the limited number of examples, and even harder is predicting when another one might happen. However, scientists have recently made progress on understanding how these supervolcanoes work due to advancements in technology. Take the Taupo supervolcano in New Zealand. Scientists have been studying it in detail as it's relatively new and still active. The last eruption was 1,300 years ago, and there have been thousands of earthquakes in the area since then. Researchers are taking advantage of this recent activity to learn more. For instance, they've been using GPS and satellite radar to monitor the ground above the caldera for any sign of movement. This data helps them determine if magma is moving toward the surface and if the pressure is building up. Scientists are also measuring gases that come from the crater lake that sits within the caldera. If there's an increase in sulfur dioxide gas, it could be a sign that magma is rising. Another technique scientists use is called continuous GPS monitoring, or CGM. CGM uses networks of GPS stations to track even the smallest changes in the Earth's surface. It's similar to how GPS works on your phone. Your phone receives signals from satellites to figure out where you are, but instead of telling you where you are, CGM tells scientists how much the land around the volcano has moved. And this data can help scientists identify early signs of unrest, which may indicate magma movement beneath the surface. Researchers are constantly working to improve the accuracy of these techniques. For example, the Unquiet Earth project uses an advanced GPS network to monitor volcanoes in New Zealand, including Ruapehu, another volcano in the country. The project aims to provide real-time monitoring of volcanic unrest to help predict eruptions. This research is expected to help better understand Taupo's behavior too. The goal is to eventually provide more accurate warnings and prepare communities near the volcano for potential eruptions. While Taupo is relatively young, scientists are also turning to other supervolcanoes to better understand the mechanisms behind these eruptions. Take the Yellowstone supervolcano in Wyoming, for example. Yellowstone is probably the most famous supervolcano, and for good reason. It's the largest in North America, and it's been the site of some of the most powerful eruptions in history. 3 major eruptions have shaped the landscape of the region over the past 2.1 million years. Yellowstone's supereruptions created the 3 major calderas or craters in the area: the Huckleberry Ridge, the Mesa Falls, and the Lava Creek. Each of these calderas is larger than the last, and the youngest, the Lava Creek caldera, is home to the Norris Geyser Basin. It's interesting to note that Yellowstone is actually a hotspot, meaning that it sits above a particularly hot area in the Earth's mantle. As the tectonic plates move, new volcanoes will form in the same place. So even when the Yellowstone supervolcano eventually erupts again, future eruptions won't necessarily happen at the same spot. Instead, they'll continue to form along the same hotspot, creating a line of supervolcanoes across the western United States. Scientists have been studying Yellowstone closely for decades, and they've developed several tools to monitor the volcano's activity. One of the most important tools is the Yellowstone Seismic Network, or YSN. The YSN consists of about 250 seismometers that are used to detect earthquakes in the Yellowstone region. Earthquakes can be caused by a variety of factors, including the movement of tectonic plates and the buildup of pressure beneath the surface. By monitoring seismic activity, scientists can identify areas where magma may be accumulating beneath the surface. For example, in the early 1980s, scientists detected a swarm of earthquakes near the Norris Geyser Basin in Yellowstone National Park. These earthquakes were unusual because they occurred in an area that was not seismically active. The swarm lasted for several months and was followed by an increase in the frequency of eruptions in the geyser basin. The increased seismic activity and the changes in the geyser basin's activity provided evidence that magma was moving toward the surface. While no eruption occurred, the event highlighted the value of the Yellowstone Seismic Network and other monitoring tools for detecting changes in the volcano's behavior. Another tool scientists use to monitor Yellowstone is the Yellowstone Volcano Observatory, or YVO. The YVO uses a variety of techniques to monitor the volcano's activity, including GPS, satellite radar, and infrared sensors. The YVO collects data on the shape, temperature, and gas emissions of the volcano. Changes in these parameters can indicate changes in the volcano's behavior. For example, in 2014, the YVO detected a slight uplift in the eastern part of the Yellowstone caldera. This uplift was later confirmed by GPS measurements, and it suggested that magma was pushing up from below the surface. While the uplift continued for several months, it did not result in an eruption. The YVO continues to monitor the volcano for any signs of unrest. Studying Yellowstone is helping researchers learn more about the inner workings of supervolcanoes. Scientists are also learning about the environmental impact of these eruptions. Studying past eruptions can teach us about the impacts of future ones. For example, scientists have studied the impact of the Yellowstone supervolcano on the surrounding environment. They found that the ash and debris from the eruptions had a significant impact on the local ecosystem, killing off plants and animals and changing the landscape. However, they also found that the area recovered over time and that the eruption ultimately led to the formation of new habitats. Understanding the impact of supervolcanoes on the environment can help us better predict the impacts of future eruptions. For example, by studying the way that past eruptions have affected the climate, we can better predict the effects of future eruptions. This knowledge can help us develop strategies to mitigate the damage caused by supervolcanic eruptions and better understand their role in shaping the planet. So, as scientists continue to study supervolcanoes like Taupo and Yellowstone, they're developing better and better tools to detect the signs of an impending eruption. While it's impossible to predict when a supervolcano will erupt, researchers hope that these tools will give us some warning before it's too late. Thanks for watching this episode. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So to all of our patrons, thank you for what you do to make this happen. If you're not a patron, but you want to learn more about what that means, you can go to our support page.